Hello, this is Joshua Butcher. We're going to look a little bit at subnetting from a CIDR notation. Now this video will assume you at least have an idea what an IP address is and what a network ID is and a broadcast ID and stuff like this, but it will assume basically that maybe you've been studying subnetting but having kind of a hard time being able to get good answers or really wrapping your head around it. There's many approaches to looking at this, so hopefully this approach will help you as just one of the many different options you can look at to understand this. First things first, we're going to look at, I have an IP address here of 192.168.60.55 with a CIDR notation of /20. What I need to be able to figure out is the network ID and the broadcast ID. In order to figure those out, I need to understand what that CIDR notation of /20 even means. That represents how many bits are turned on within my subnet. So what will help me every time I do this, I first create myself a simple little chart. I'm going to go ahead and make myself a chart right now, and you don't have to use any graphical tools to do this, but I use a chart here just because it's easy enough on here. But I just write this on any piece of paper or anything I'm working with to make this kind of work out. Let me make my letters bigger. There we go. And basically I just start off from here and go to the left. 1, 2, and it doubles this number up to 128. 4, 8, 16, 32, 64, and 128. This isn't necessary to write this down, but it's just going to help my mind as I try to wrap my head around what in the world's going on. So let me get back to the CIDR notation. First of all, what does this even mean? So when we're talking about a subnet mask, usually you might be used to seeing 255, 255 dot something along those lines. Let's see what those really look like. If I did 20 bits turned on, let me go ahead and start that, doing them in 8-bit rotations. 1, 2, 3, 4, 5, 6, 7, 8, dot. 1, 2, 3, 4, 5, 6, 7, 8, dot. That's 16 current turned on. That would be equivalent to /16. 17, 18, 19, 20. Then 1, 2, 3, 4. And all the rest from that point on will be zeros. So this is equivalent of all the ones turned on is the equivalent of turning all these on and adding them together. That would equal 255. So a subnet for this particular IP range would be 255 dot whatever this would be. That would be these 4 bits all turned on, which is these numbers all combined. 128, 192, plus 32 is 224, plus 16 is 240. So that would be 240.0. That's what the subnet really works out to. I don't need to translate that to make sense of this. I'm just doing that so I can wrap my head around what I'm talking about. What's helpful though is really looking at this here. Now I can attempt to translate every single one of these into binary, but that is totally unnecessary. What I need to do is translate just a particular one into binary to really make sense of this. So I'm going to go here and I'm going to specify which one that matters. In this point, these are all on, these are all on, these are all off, so the third octet is my focus. Let me highlight over here, third octet. That's my focus. Since I know that's my focus, I already know some information about the other fields. These are all turned on, so I know it's going to be 192.168. This as well, 192.168. These will be consistent with every single number possible in the range. The third row here is what I'm really trying to figure out. And if these are all turned off, that would be 0. But if they were all turned on, that would be 255. So what I need to figure out now is just these two simple values. To figure that out, I need to translate this number here into a binary value and map it to this. So I'm just going to go ahead and put in some fillers here. We won't do anything it recognizes here, so we'll do X's. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot. And I just want to move this so I can see what I'm talking about here. There we go. So I want to turn this now into binary. I'm looking at converting the number 60. All I really do is look at this chart here. Can I take 128 out of 60? No. Can I take 64 out of 60? No. Can I take 32 out of 60? Yes. That leaves me with 28. Can I pull 16 out of 28? Yes. So that leaves me with 12. Can I pull 8 out of 12? Yes. Can I pull 4 remaining? That would be 4, and the rest remaining would be zeros. Then dot, and then it doesn't even matter again, because I don't care about any of those other values right now. These are the ones I need to map it to. So this is when the computer sees this, and the computer sees this, it determines the next row here of exactly what the IP address would be, or that particular number. Let me just scan up here. And this does this with something called a logic table. Basically, it'll take the two values, and if they're both equal true, it'll make it true. So if they're both 1, it'll make it 1. It might help to think of this almost a multiplication. 0 plus 1, 0 times 1 is 0. 0 times 0. 1 times 1 is 1. 1, 0, 0, 0, 0. Here we have this number identified. All I need to do now is really translate this number, and this will give me my network ID. So this number is not that bit, but these 2 bits turned on. Those 2 bits combined equals 48. That is my network ID. Pretty good to go so far. Now I just need to figure out what would be the next possible network ID in the list, because whatever the next one is, the number right before it would be the broadcast ID. So the next possible one, I have to figure out what that would be. This is determined by looking at something called the magic number. This is the last bit that's turned on. Whatever that is the increments and how many they go up by. So in this case, it's the 4th one. So I got 1, 2, 3, 4. They go up in increments of 16. So 48 plus 16 minus 1 will equal my broadcast ID. If I didn't do the minus 1, it would be another network ID for the next possible range. So all I need to do is do 48 plus 16. Well, 48 plus 16 is 64. Minus 1 would be 63. That's my network ID. That's my broadcast ID. Now for the actual range I can use, it's very easy at this point. So 192.168.48.1, I can't assign a computer a .0 address, through 192.168.63.254, because I can't assign a computer a .255 address. This is my answer. This is how I came about it. Hopefully this is starting to make sense. Let's look at another example or two so we can make sure we wrap our heads around this properly. In this next example, we're going to look at finding the network ID, the broadcast ID, and the usable IP addresses that seem to go in common here with the 172.10.85.60 with a /22 CIDR notation. Once again, to help myself out, I'm going to go ahead and make my quick little chart just for my own brain. I'll make a little 8 chart. Here we are. Oops, it moved over really far. I'll put it right here. I'll insert table 8. And I'll just bring this up 1, 2, 4, 8, 16, 32, 64, 128. Now I need to figure out which octet do I want to focus on, because I don't feel like translating all of these into binary. Which one is it? Well, anything really you can tell right away, being it's between 16 and 24, it's going to be the 3rd octet, but I'm going to go ahead and work this out anyway. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's 16, 17, 18, 19, 20, 21, 22. That leaves me with 0, 0, then 0, 0, 0, 0, 0, 0, 0, 0. Now I got this figured out. What this means here. Of course, if I wanted to actually know what that number was, I could add all those together. 1, 2, 3, 4, 5. I could add these guys together here, the 6, and actually see what that /22 means. I don't want to do that right now. All I do know right away is it's going to identify my magic number pretty quick. Now I just need to figure out, so I know I'm dealing with a 3rd octet. That's all I really care about. Let me go ahead and highlight that. The 3rd octet, which means some of the information I'm able to fill in already. I got 172. Oops. 10. 0. 172. 10. 255. I just need to figure out what these values are now. In order to do that, I'll need to find this number and then add the magic number to it and subtract 1, and that'll be this. So I gotta find this first. 85, so I need to translate 85 into binary. Let me do it over here. Dot. Can I pull 128 at 85? No. Can I pull 64 at 85? Yes. And I just have to slowly start doing the math for this. That leaves me with 21. Can I pull 32 out of there? No. Can I pull 16 out of 21? Yes. So 16 from 21 is 5. Can I pull 8 out of 5? No. Can I pull 4 out of 5? Yes. No. Yes. That's what this turns out to be. There's my basic number. What I need to do now is do the process of ANDing. Determine what's left. 0, 1, 0, 1, 0, 1, 0, 0. Those are the ones that line up. I just need to figure out what those fit in the chart. So 64. Let me go ahead and highlight this. 64 plus 16 plus 4. And whatever number that comes out to be is this number here, which would be 84. Now I need to know the next range that comes down. Remember these work. This last little bit here turned on is what's called the magic number. That's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Intervals in 4. So if I add 4 to 84, that would be the next possible network ID in the list. The one before that must be the broadcast ID. So that'd be 88 minus 1 would be 87. Now I have my broadcast address. This now I can work out the rest. 172.10.84.1 through 172.10.87.254. Now I'm starting to work my way down and see how well this works. Let's just do one more example. I would recommend you pause the video at this point and try to work this out, and then you can resume it again and see how it works. I'm going to assume you'll do that in your own timing. Here I need to figure out exactly which octet I want to focus on. Once again, this is my key here. I'm going to go ahead and figure this out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. 1, 2, 3. That's where I'm left on here. So I know we're focusing on the third octet. The third octet. Now I can see I have some fields I can fill in. 172, 10, 16, 172, oops, I'm sorry, 60, 10, 60. I just need to figure out what this number is and this number is. In order to figure that out, I need to find out what in the world is my network ID. To stay consistent here, we'll do this by ANDing. Dot. I just need to figure this out and translate that in. Now my little chart's missing, so maybe my brain won't like this. So I'm going to go ahead and write it down. Like I said, I would normally write this on any piece of paper. Let's fill this in. 1, 2, 4, 8, 16, 32, 64, 128. Now I just need to line this up. I'm now translating the number 16 into binary. I can't pull 128 out of 16, or 64, or 32, but I can pull 16, and the rest would be zeros. So here's where we are, done with this. Now all I need to figure out is exactly doing the process of ANDing again. Which ones equate with a 1 left in it? 0, 0, 0, 1, 0, 0, 0, 0. Sounds pretty familiar, right? Looks like the top one. Still the fourth one over. 1, 2, 3, 4. The number is 16. So the next possible hop down the list here, the magic number will give me that idea what it is. That's the fifth one over. 1, 2, 3, 4, 5. That's 8. I would do 16 plus 8. That would tell me the next network ID in the list. So the one before it must be the broadcast ID. So 16 plus 8 minus 1. 23. Now the usable IPs in here or everything in between, 172.10.60.17, 172.10.60.22. Now this is the usable range. Same type of process, even a little less complicated than the other one we're looking at, or more, depends on how you look at it. But the key here is knowing which one I'm looking at, and once I know the octet I'm focusing on, I can then work on just translating that particular section. Don't have to worry about every single little bit. Especially when I mess up maybe some basic math, I can get myself in trouble, and that is the easiest way to get in trouble with the math of IP subnetting. Hopefully this information is helpful for you to be able to figure this out. There's lots of other tricks that are out there, and we will be visiting other tricks here soon.